Good afternoon. Good afternoon. Myself, Sreeja Pekkat, Associate Professor in the Department of Civil Engineering. I welcome you to the live session regarding the NPTEL MOOC on Engineering Hydrology. I am the course instructor for the NPTEL MOOC on Engineering Hydrology. So this is our second live session. First live session regarding the course is over 1 month back. And this is second one. And this, as those who are attending this particular course on NPTEL, you know already, this is a 12-week course. So out of 12 weeks, we have already completed 8 weeks. 8th week we'll be completing this week. Next week, the 9th week contents will be uploaded. So if there is any clarifications required regarding the topics which we have covered in the course, you can ask queries, or in case you are not present in lab, you can send email personally or through the NPTEL portal, NPTEL email ID, you can contact me. So till now in the Google Sheets, I didn't see any queries raised. So some of the students usually contact me personally. So that may be the reason they are not coming on live. So I've clarified through email also. So just I'll give a brief introduction up to what we have stopped, completed till now, 8th week. So those who have missed the first live session, we know already this particular course is having contents regarding the basic course engineering hydrology, those who are studying civil engineering, agricultural engineering, and as a part of the curriculum, if they are having in this particular course, everything related to the fundamental course, UG curriculum, is incorporated in this particular syllabus. Out of 12 weeks course, we'll be covering the entire course is divided into 3 parts. That is water, which is present in the atmosphere, which is present on the ground surface, and also beneath the ground surface. In the first month, we have covered the topics related to atmospheric hydrology, and we have discussed a little bit about the subsurface hydrology. So whatever concepts, basic understanding required as far as the water which is present in the atmosphere in the water vapor required for a hydrologic engineer is covered in that particular module on atmospheric hydrology. After that, once we completed the contents related to atmospheric hydrology, we have moved on to subsurface hydrology. Subsurface hydrology, I explained in the just beginning of the lecture itself. Subsurface hydrology, as part of this particular course, we are not completely covering subsurface hydrology. We have covered only the region which is beneath the ground surface, which is unsaturated. Water which is present in the ground surface, beneath the ground surface, can be divided into 2 zones. One is saturated zones and the other one is the unsaturated zone. Saturated zone, all the pores in the porous media or soil or rocky strata, all the pores are filled with water. That is saturated region. And in the unsaturated zone, pores are filled with air and water. As a part of this course, we have covered only the unsaturated region. What is required as a part of hydrology, those topics are covered in this particular course in the module of subsurface hydrology. In that, we have studied the process termed as infiltration, methods of determination of infiltration, experimental, empirical methods, and also theoretical equations we have derived. Commonly used equations for computing infiltrations have been derived. And after that, after completing the measurement or estimation of infiltration, we have seen the concepts related to ponding time and ponding depth. Ponding time is the time at which the water starts during the rainfall. Initially, some amount of rainfall will be infiltrated into the ground, and after certain time, it starts overflowing on the ground surface. So just start ponding on the surface. That particular time is the ponding time, and ponding depth computation also we have completed under the subsurface hydrology topic. Some of the numerical examples regarding each and every topic coming under the engineering hydrology course I have covered at the end of every topic. Once we have completed the subsurface hydrology, we have moved on to surface water hydrology. Surface water hydrology, mainly we were discussing about the stream flow measurements. What is stream flow? You have studied already that it has got three components. One is the runoff, overland flow, or runoff or overland flow. Second one is the groundwater component, and third one is the interflow. Groundwater component is coming from the saturated region. Beneath the ground surface, I've already told you, saturated and unsaturated region. These regions also contribute water to the stream flow. So the components of stream flow, when we talk about, it has got three components. One is the surface flow component, that is the runoff. Second one is the component flow, which is coming from the unsaturated region, that is termed as the interflow. And third component is the base flow, that is the one which is contributed by the groundwater. And these stream flow measurements we have studied, and estimation of stream flow in a particular river or channel also we have studied, and some of the numerical examples also we have solved in the particular topic. After that, we have seen how can we represent the stream flow. Graphically, how can we represent? That is by making use of the hydrograph. Hydrograph is nothing but the graphical representation of stream flow. That is, we'll be plotting Q. Q is the notation which is used for stream flow in this particular course. Q versus time. If you are having, if you are not considering the groundwater component, we'll be calling that hydrograph as the direct runoff hydrograph. Once we have gained the understanding regarding the hydrograph, we have moved on to hydrologic analysis. Hydrologic analysis gives us idea about the hydrograph theory, and by making use of hydrograph, how can we compute, by making use of different types of hydrographs, how can we compute the discharge at the outlet of a watershed? Different types of watersheds also we have covered. So hydrographs are of different types. Unit hydrograph, S-curve, and third one is the instantaneous unit hydrograph. So these three concepts, unit hydrograph, S-curve, and also the instantaneous unit hydrograph, before starting those things, we have studied the linear system theory based on which these hydrographs have been derived. So linear system theory is utilized for the development of this unit hydrograph and S hydrograph and instantaneous unit hydrograph. If we know any one of these, unit hydrograph or S hydrograph or instantaneous unit hydrograph, we can derive other from the one which is known to us. And once the concepts regarding the unit hydrograph, S-curve and the IUH is covered, then from one to other, how it can be converted, that also we have studied in this particular topic. Comes under hydrograph analysis. In the hydrologic analysis, we have studied only the hydrograph and the linear system theory. Then we have moved on to hydrograph analysis, subsection of the hydrologic analysis. And hydrograph analysis, we have studied conversion of one instantaneous unit hydrograph to unit hydrograph. Unit hydrograph, if S-curve is available to you, how can we derive the unit hydrograph, and how can we derive unit hydrographs from the storms or the rainfall which are having different durations. All these things based on the linear system theory, principle of proportionality and the principle of superposition, we have seen in detail, and numerical examples regarding each one is solved. So I think up to 8th week we have covered the hydrograph analysis. Hydrograph analysis is not completed. Remaining part of the hydrograph analysis will be starting in the 9th week, coming week. So once the concepts regarding the unit hydrograph, instantaneous unit hydrograph, and the S-curve is completed, we'll move on to the synthetic unit hydrograph. Synthetic unit hydrographs are required for the catchments where we do not have the data regarding the runoff and the rainfall. That is mainly for the ungauged catchments. In the case of ungauged catchments, we can derive the hydrograph by making use of the details or the data from the gauge catchment, which is geomorphologically similar. Because for carrying out any type of rainfall runoff modeling or any type of hydrologic analysis in a ungauged catchment, we need to have some details regarding the rainfall and runoff. So if it is an ungauged catchment, we won't be having that. So it can be derived by making use of the hydrographs which is available for the gauge catchments, which are geomorphologically similar to that of ungauged catchment. Two different methods have been described. Fundamental methods are described in this particular course for deriving the synthetic unit hydrographs for the ungauged catchments. Once we finish, those topics will be covered in the coming week. And after that, we'll be moving on to week 10 is exclusively for hydrograph routing. Hydrograph routing means if we know the flow characteristics at the upstream of a channel or upstream of a river, by making use of that data, those details, we can compute or estimate the flow details at the downstream section. So this is very much needed if we are going to carry out the river modeling or channel design and all. So routing, when we talk about, very fundamental way, basic way I'm explaining over here. In detail, you can see in the course. Detailed lectures along with the detailed description along with the numerical problems have been explained in the week 9 and week 10. Week 10 is hydrograph routing, and in that we are covering the reservoir routing and the channel routing, so that we'll get the flow characteristics at the downstream of the reservoir and also different downstream sections of the channel or river. After completing the hydrograph routing, we'll be moving on to in the week 11. That is, this week is week 8, and in the week 11 we'll be moving on to hydrologic statistics. As far as this particular topic is concerned, rainfall runoff modeling and hydrologic variables are concerned, those are having so much of randomness. So in order to have the analysis of those variables, we need to have basic understanding about statistics and probability. So in a minimal way, which are required for fundamental understanding of the analysis of the hydrologic variables, we have the topic will be covering different types of statistical methods for understanding the variables, understanding the central tendencies and all, and descriptive statistics, and regarding the distribution, in which what type of distribution, probabilistic distribution a particular variable will be following. So in order to have the understanding of the different probabilistic distributions which will be commonly used for the analysis of discrete and continuous random variables are covered. Discrete random variable, for your understanding, I am telling, that is discrete means, for example, if you're talking about the number of rainy days is discrete. So in other way, if rainfall data we are describing, it is continuous, or stream flow data continuous. So, but number of rainy days is exactly, we can count the days and it is described in a discrete way. Now, after understanding the basic probability and statistics regarding the hydrologic variable analysis, we will be moving on to the frequency analysis. Frequency analysis also, different methods are there, and those fundamental approaches we have explained in the 11th week. And as far as hydrology is concerned, extreme value, hydrologic variables are concerned, extreme value analysis is very, very important, because we are facing, in a layman point of view, if we talk about different parts of the country, as far as India is concerned, during monsoon season, some of the urban cities and some of the rivers will be overflowing. We are facing the problem of flooding. And at the same time, during summer season, different locations are facing the problem, different areas, districts are facing problems of drought. So all these are extremes. When we talk about the hydrologic process, flood is the one extreme and drought is coming on the other extreme. For the analysis, excess rainfall may be leading to the, in addition to that, other factors are also there. But excess rainfall during the monsoon season, high intensity, short duration rainfalls will be leading to flooding in the particular locality. And at the same time, during summer season, during the monsoon season, if you are not getting the sufficient amount of rainfall, it may be leading to the drought in particular regions also. So for the analysis of these types of extremes, we need to have some idea about the extreme value analysis. Very few methods, very often we use, have been explained in the lectures, that you can go through that in the 11th week. After that, we have moved on to hydrologic design. In that design's domain, design flood is explained based on the concepts of probabilistic understanding. And with that, fundamental topics regarding the course engineering hydrology, majority of the topics have covered, and advanced level, so much is there to expand, but fundamental way, undergraduate level, all the topics will be covered by the 12th week. Since this much is about, since there is no query regarding the topics which we have already completed, I'm going to wind up the live session now. If you are facing any problem after going through the lectures in the coming weeks, you please feel free to contact me through my email ID. Email ID, everything is given along with the lecture. Thank you very much.